Okay, let us start, kids. So in the last class, we had started with the exact differential equation. Can anybody tell me what is exact differential equation? How you're going to check the given differential equation is it exact or not? Anybody? How will you check that given differential equation is exact or not? Am I audible to all the kids?
Yes, ma'am.
Yes. Tell me how will you check that given differential equation is exact? So you will be given differential equation like this. Okay. Wait, let me write it first. So this is a differential equation, and you have to check that whether this given differential equation is exact or not. So how will you check that? So what you were saying, Mandar? So differentiating partial with respect to
X.
x होगा या y होगा?
X होगा.
You sure x होगा?
Y होगा.
Delta m upon delta m upon y is equals to delta n upon x.
Yes. So you're going to differentiate m partially with respect to y and n with partially with respect to x, and then you will check whether they are equal or not. If they comes out to be equal, then you will say that the given differential equation is exact. And if the given differential is exact, then what is the solution of exact differential equation? The solution of exact differential equation क्या हो जाएगा बच्चों?
Integration of m.
Yes, it is going to be integration of m with respect to x, treating y constant plus integration of only those term of n not containing x. Please understand that, kids, we don't have to write all the terms of n, only those terms of n which are not containing x. Not containing x. So that you have to keep it in your mind, that formula is this. Is it with respect to y is equals to integration constant. So this is what we have studied in last class. You'll be given differential equation which will be in the form of m dx plus n dy equals to 0. The dx coefficient will be treated as m of x comma y, and dy coefficient will be treated as n of x comma y. And then you're going to differentiate them partially. M you're going to differentiate partially with respect to y, and n partially with respect to x. And then you will check whether they're equal or not. If they are equal, then you will say that the given differential equation is exact, and the solution of exact differential equation is given by this formula. So this is what we have studied in last class. Now let us start with today's topic. In the last lecture, Faizan had questioned me, ma'am, what if my given differential equation is not exact? What if del m by del y is not equals to del n by del y or del x? So in that case, what you're going to do, kids, you're going to make them exact. How will you make them exact? That is your next topic. And your next topic for today's class is integrating factor. This is our next topic, kids, integrating factor. If your given differential equation is not exact, you are going to make it exact, but by multiplying some factor, and that factor is called as integrating factor. Did you understand how we are going to make our given differential equation an exact differential equation? So of course, whatever given differential equation is there, that is not exact, and we have to make it exact differential equation by multiplying it with some factor, and that factor is called as integrating factor. Okay. Now integrating factor will have different formula depending on what kind of differential equation you are having. So there are some rules. So rule number 1. So listen. So if we are having m dx plus n dy, this is my given differential equation, kids. So if I'm having m dx plus n dy, this is my differential equation. If it is a homogeneous differential equation, if it is a homogeneous, you all know na, m in m and n, each term will have degree same, then it will be called as homogeneous differential equation. So homogeneous differential equation. If my given differential equation is homogeneous differential equation, then my integrating formula will be, the integrating formula will be 1 upon mx plus ny. So what you have to do, kids, you have to multiply this m with x and n with y. So then you're going to add them together and you're going to take its reciprocal. So you're going to get your integrating factor. Provided your mx plus ny should not be equals to 0. So this is a rule number 1, which says if a given differential equation is a homogeneous non-exact differential equation, then integrating formula will be this, which is 1 upon mx plus ny, where mx plus ny is not equals to 0. So this is our rule number 1. Now let us see what is rule number 2. Rule number 2. Rule number 2 says if I'm having a differential equation of this type, which I'm writing in front of you all. If I'm having a differential equation of this type, f1 x comma y dx plus f2 x comma y x dy equals to 0. So if my given differential equation somewhat look like this, then I'm going to apply rule number 2. And in rule number 2, the formula for integrating factor is 1 upon mx minus ny, where mx minus ny should not be equals to 0, where mx minus ny should not be equals to 0. I don't think so there should be any problem in understanding when I'm going to apply rule number 1 and when I'm going to apply rule number 2. Rule number 1 is applicable when your given differential equation is homogeneous, but it is not exact. At that time, you're going to use the formula for integrating factor as 1 upon mx plus ny. When your given differential equation look like this, like f1 x comma y, some equation in terms of x and y dx plus some equation in terms of x and y x dy. At that time, you're going to use formula for integrating factor from rule number 2. Let us see what is rule number 3. Now, if your formula doesn't fit in this thing, what's wrong? If your formula doesn't fit in rule number 1 and rule number 3, at that time you're going to use rule number 2, then at that time you're going to use rule number 3. And rule number 3 says if del m by del y minus del n by del x upon n. So this thing you're going to calculate, kids. If your given differential equation does not fit in rule number 1 and rule number 2, then you're going to apply rule number 3. And rule number 3 says calculate this factor del m by del y minus del n by del x upon n. So all these you have calculated already. You subtract them and you divide same thing by n. If it is coming out to be a constant, or you can say a function or a function of x only, and function of x only, how do we write? We write it by f of x. So we calculated this factor del m by del y minus del n by del x upon n, and we got it as constant. Yeah, you can say, we got it as some function of x only. Then you will say, then you're going to apply this formula for integrating factor. And the formula for integrating factor is this e raised to integration of f of x dx. And from where this f of x has come? From here, the factor which you have calculated above. This from here, it will come f of x. So this factor you have calculated. So whatever you have got, so that too you will denote it by f of x, and that f of x you are going to put it in this. So this is the formula for integrating factor. Now rule number 4. Now rule number 4 is what? If del m by del y minus del n by del x divided by minus m. Now at this time, suppose you're not getting function of x only. There are some other function y is also available. So at that time you cannot use rule number 3. So you have to see rule number 4. So rule number 4 says calculate this term del m by del y minus del n by del x divided by minus m. So if it comes out to be a constant, or you can say a function of y only, at that time you're going to use rule number 4, and the formula for integrating factor in rule number 4 is this: e raised to integration of fy dy. So these are the rules for calculating integrating factor, which totally depends upon how your differential equation looks like. So in whichever rule your differential equation fits in, you're going to use that particular integrating formula. Is this clear to all the kids?
Yes, ma'am.
Yes, ma'am.
Okay, so let us revise all the rules one by one. So tell me, when are you going to apply rule number 1? What is integrating factor first of all? What is integrating factor first of all?
Ma'am, agar equation
Yes. Yes.
अगर पार्शियल डिफरेंशिएशन वाला वो सेटिस्फाई नहीं करता है तो मतलब वो
हाँ, तो
एग्जैक्ट
integration
डिफरेंशियल
factor
इक्वेशन नहीं है तो उसको उसमें कन्वर्ट करने के लिए वेक्टर का
integrating factor use
मल्टीप्लाई
करेंगे.
Okay, so when your given differential equation is not exact differential equation, not exact, how you got to know that given differential equation is not exact? That because we calculated del m by del y minus del m by del y and del n by del x, and we got that they are not equal. So we got to know that the given differential equation is not exact. So we are not going to stop there itself. We are going to multiply my given differential equation with some factor, so that ki my differential equation kya ho jaye, exact differential equation ho
Exact
jaye.
differential.
So for that factor is called as integrating factor. So
Yeah,
integrating
ma'am.
factors, there are different formulae for different type of differential equation. So first type says if your given differential equation is what? Homogeneous non-exact differential equation, that time you're going to use this rule number 1, and in rule number 1 the formula for integrating factor is 1 upon mx plus ny. Rule number 2 says if your given differential equation looks like this, f1x comma y dx plus f2x comma y x dy, at that time you're going to use this formula for integrating factor, which is 1 upon mx minus ny. Rule number 3 says if your given differential equation is not homogeneous, that does not fit in rule number 2 also, and at that time you're going to apply rule number 3, for that which you have to calculate this factor del m by del y minus del n by del x upon n. So if this factor comes out to be a constant or a function of x only, then integrating factor formula will be e raised to integration of f of x. And the same is with rule number 4. In rule number 4, we are dividing it by minus m. That's all. And the function should be in terms of y only, or it should be a constant. The integrating formula will be e raised to integration of f of y dy. So let us start with the problem, kids. Let us start with the problem, kids, and then I'll be explaining you one problem, and then next problem onwards you're going to do on your own. So let us start. It is not getting selected. Question number 1. So kids, if you find any difficulty in understanding any step, you do ask me. I'll explain you all. So I'll be explaining you all one problem, and the next problem onwards you are going to do on your own, and you're going to tell me which rule we are going to apply in this particular formula, in this particular problem. So this is my first question. Solve x squared minus 3xy plus 2y squared dx plus 3x squared minus 2xy dy equals to 0. So this is my given differential equation, kids. So let us check first the given differential equation is exact or not. So let us check that first. So how am I going to check that? So from the given differential equation, I'm going to write down m and n. So can anybody tell me what is m and n from this given differential equation? What is m and what is n?
x square minus
X
3xy
square
plus
minus
2xy
3x plus 2.
X is M.
X square minus 3xy plus 2y square. So this is my m, and n x comma y is going to be 3x square.
Minus 2xy.
Okay, now next, what am I going to check? What to check?
Exact differential equation.
So for that you need to differentiate them partially with
Lambda
respect to
m
y.
on lambda y.
Yes, and it should be same as differentiating n with respect to x partially. So if this thing comes out to be equal, then I will say that given differential equation is exact. So let us check that first, whether they comes out to be equal or not. So I'm differentiating m here partially with respect to y. So I'm differentiating m partially with respect to y means I have to treat other variable as constant. So here is your m. You differentiate this m with respect to y and treat x as constant. Tell me, what will be the integration of what will be the differentiation of x square with respect to y?
0.
If I differentiate,
0.
okay, why? Because we are differentiating with respect to y, no? So x square will be treated as constant. So derivative of constant is 0. Now in minus 3xy, what is the constant?
3x.
Minus 3x.
Okay, and derivative of y with respect to y is going to be 1
Y.
plus. What is this? 2y square.
And next
What
term
will be
will
the
be
derivative?
4y.
Absolutely right. So derivative of 2y square is going to be 4y. So finally I got what? So minus 3x plus 4y. So this is what I got for differentiating m partially with respect to y. Now let us differentiate n partially with respect to x. So here is your n, differentiate it with respect to x and treat variable y as constant. So derivative of 3x square will become
6x.
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 Absolutely right. Minus, what is constant in 2xy?
Y is a constant.
Y.
So x
2
is a
is
constant.
constant, y is constant. And derivative of x with respect to x is going to be 1.
1.
So final answer, you got it as 2x minus 2y. Or 6x minus 2y. Are they equal, kids? Can you find them equal? Can
No,
you find
ma'am.
them equal, kids? No. So since del m by del y is not equals to del n by del
Del m
x,
by del
what
x
you what? So what you will say? Therefore, the given differential equation is
is
not
not a perfect,
Not perfect.
exact differential equation.
Not exact.
is
Not exact.
is not exact differential equation.
No, we
Okay.
have to convert it.
So if it, so we are going to make my given differential equation into exact differential equation. So how am I going to make my given differential equation into exact? Okay, how am I going to do that, kids? So this is my differential
Integral form.
equation,
Integral.
integrating factor. So
Integrating
tell
factor.
me, in which rule number my this given differential equation fits in?
First rule.
Why it is fitting in first rule?
And because both the m and n are homogeneous.
Okay, both the m and n are homogeneous because आप देख सकते हैं in each term of this function m there are 3 terms in m: x square, 3xy and 2y square. Okay, in each term is of degree 2. X square is of degree 2, x into y, x degree is 1, y degree is 1, x 1 plus 1 will become 2. So this term is also of degree 2, 2y square it is of also degree 2. So this function is homogeneous. Whereas this function n, there are 2 terms and each of this term of degree 2. So n is also a homogeneous function. So yes, it fits in rule number 1. Since the given differential equation is homogeneous, non-exact. Did you understand why am I saying non-exact?
Yes, ma'am.
Non-exact differential equation. Therefore, integrating formula will be 1 upon mx plus ny. So let us calculate 1 upon mx plus ny. What is your m in this? So that m you have to multiply with x. Okay, kids? That m you have to multiply with x. So after multiplying m with x, what am I going to get? X square will become x cube. Tell me, I'm multiplying m with x.
X
So it
cube
is going to
minus
be
3x
X
square
cube
y.
minus 3x
yes,
square y plus 2x
x cube minus 3x square
3x
y
square y.
plus
Xy square.
plus
Plus
2xy square.
2xy.
Okay.
Absolutely right. So 2x y square. So we multiplied m with n. Now plus, now you multiply n with y. So what am I going to get? 3x square y minus 2xy square. The c ones, I'm multiplying n with y. So it will become 3x square y, then minus 2xy square.
Y square.
Is there any term which is getting cancelled out? I think this term and this term is getting cancelled out. This term and this term is getting cancelled out. What is left now? 1 upon x cube. So this is your integrating factor which you have to multiply to your given differential equation. My given differential equation is this. So I'm going to make it star. So multiply my integrating factor in star. So multiplying integrating factor in star. So tell me what is going to be your final answer. So after multiplying, what you will get? Tell me quickly. So you have to multiply. So 1 upon x cube, x square minus 3xy plus 2y square dx plus 1 upon x cube. I have to multiply integrating factor to my given differential equation, which is what this is what I'm doing over here. So far what we did, we first this was my given differential equation. My screen is visible to all the kids.
Yes, ma'am.
Yes, ma'am.
Okay, so this is my given differential equation. From this, I calculated del m by del y and del n by del x. I got that they are not equal. Therefore, the given differential equation is not exact. But my given differential equation is homogeneous. So therefore, the integrating factor will be 1 upon mx plus ny. So we got it as 1 upon x cube. So that we are multiplying throughout to my given differential equation. So this was my given differential equation and I multiplied throughout with 1 upon x cube, which was my integrating factor. Now you multiply 1 upon x cube inside. So what am I going to get with kids? I'm multiplying 1 upon x cube inside. So it is going to be 1 upon
1
x
upon x
minus 3y upon x square plus 2y square
2
upon x cube dx plus 3 upon x minus 2y upon x square dy equals to 0. Is it clear to all the kids? What did I do over here? I
Yes,
just
ma'am.
multiplied 1 upon x cube inside. Now, so now new m and n you all have got. New m and n. Forget about the old m and n. Now new m and n you have got, so that you are going to consider. So 1 upon x minus 3y upon x square plus 2y square upon x cube. And n is 3 upon x minus 2y upon x square. So this new m and n you have got. And now if you will calculate del m by del y and del n by del x, then you are going to get them same. They are going to come out to be same, but that no need to check it again. They are going to be same after calculating del m by del y and del n by del x. So directly, therefore, the given differential equation is exact. Therefore, the given differential equation is exact. Now you apply the formula for what? Formula for solution of exact differential equation. Therefore, the solution of exact differential equation is given by tell me what was the formula? The formula was integration of m with
of
respect
m
to
with
x,
respect to y
treating y constant, plus integration of those term of n not containing x with respect to y and equals to integration constant. So tell me what m you have got over here. So write down that m. So m I have got over here as 1 upon x minus 3y upon x square plus 2y square upon x cube dx plus, tell me which term you will write in second integration. Only those term of n not containing x. So what is going to come in? This.
Nothing.
Nothing will come.
Nothing will come, no? So 0. So there's no term which is containing, there's no term which are which are without x. So the second term will not come. So you'll be left with only this. So you are left with this 1 upon x minus 3y upon x square plus 2y square upon x cube. And you have to treat y constant. Integrated with respect to x is equals to integration constant. So tell me what is the integration of 1 upon x?
Log x.
Log x.
Okay,
Log.
absolutely right. Log x minus. What is constant in it? 3y upon x square. What is constant?
Y is a
dy.
constant.
3y is constant. Okay, take it outside. And what will be the integration of 1 upon x square? 1 upon x square, I can write 1 x raised to minus 2. Plus, what is constant in third term?
2y square.
2y square.
2y square. And I can write 1 upon x cube as x raised to minus 3 dx is equals to integration constant. Now you all can integrate it. So log x minus 3y. What is the integration of x raised to minus 2?
X.
It is going to be x. It is x
Raised
raised
to
to
minus 2
minus
plus 1.
1.
Minus
So
1
minus 2 plus
upon
1 is minus 1 upon minus 1. Plus 2y square. What should I write over here?
X raised to
X raised
minus
X
to
2
power minus
upon
2 upon
minus
minus
2.
2.
Absolutely right. Is equals to integration constant. Now tell me final answer is going to be log x. This minus will become plus. So 3y upon x. Why 3y upon x? Because x raised to minus 1 is there. So that will go in denominator. Then minus this 2 and this 2 will get cancelled. This minus is there. So that minus I wrote over here. And it will become y square upon x square. X square y it will come in denominator because x raised to minus 2 is there. So it will go in denominator and it will become x raised to 2 is equals to c. So this is your final answer. Log x minus 3y upon x minus y square upon x square equals to c. Is this clear to all the kids?
Yes, ma'am.
Yes.
Did you find any difficulty in any step? Tell me the flow which we did in this. Tell me the flow. First, what we checked.
The equation is exact differential equation or not.
Okay, so first we checked whether the given differential equation is exact or not. After that,
Integrating factor.
what we got? Then we got to know that given differential equation is not exact. Therefore, we are calculating integrating factor. For that, you need to understand in which rule number your given differential equation will fit. So I saw my given differential equation is homogeneous differential equation. So we use the formula for integrating factor as 1 upon mx plus n. Absolutely right. And then we multiplied throughout by integrating factor in my differential equation and we got the answer. Again, you don't have to check whether the new equation will satisfy my exactness or not. It is going to satisfy. So no need to check it again. I think question number 2 it is. Okay, take down this question and solve it and tell me what you're getting. Xy square plus 2x square y cube y dx plus x square y plus x cube y square x dy equals to 0. Okay, your time starts now. I'm giving you all 5 minutes. Just work on it and tell me what you're getting. So you first write down equation for m and n, check for exactness. If they are not coming out to be same, then you try to identify key in which rule number it will fit in, and then you calculate integrating factor. Come on, start doing it this problem and tell me whether you're able to do it or not. Are you all solving? I want everyone to solve it, okay?
वो सेटिस्फाई हो रहा है कि नहीं वो चेक करेंगे पार्शियल डिफरेंशिएशन
Okay. So tell me equation for m and n. Everyone will answer this question. Tell me what is
xy cube plus 2x square y 4
xy square plus 2x square y cube
into y bracket
into
yeah.
y. Okay, into y will also come. Okay, that's nice. Okay, what else? Next, next comma
x square y and x square y plus
X
x
square
cube
y
y square
plus
x square y
into x
plus x
x
cube
cube y
y.
square x.
2x
Okay, next. What
partial
are you all doing
differentiation
then?
to
Okay,
check
now you did to check. I have to check whether del m by del x del y is equals to del n by del x. Okay, so calculate del m by del y. Tell me what you will get.
2xy
So what you
plus
can do, you
2x
can
square
multiply
3y
this inside. So I'll get xy cube plus 2x square y raised to 4. And here I will get x cube y plus x raised to 4 y square. Okay, calculate del m by del y. What am I going to get? So in xy cube, what is constant? Hello, am I audible? Hello.
Yes ma'am.
Yes, ma'am.
So answer in xy cube, what is constant? X
y
is constant. Y is constant. You're differentiating it with respect to y.
y
So y. Yes, case, what will be the derivative of xy cube?
मैम x कांस्टेंट लेंगे और y क्यूब का डेरिवेटिव डालेंगे 3y स्क्वायर हो जाएगा
So it is going to be 3y square
x
plus
into
in
3y
2x square y raised to 4. So 2x square is constant and derivative of y raised to 4 is going to be 4y cube. So this is what we got, 3xy square plus
8x
8x
square
square y cube.
y cube.
Similarly, you differentiate n partially with respect to x, treating variable y constant. So your y is constant, derivative of x cube is going to be 3x square
Y
3x square y
plus x is to, okay, y square is going to be
4x
constant.
cube
4x
y
cube y
square
square.
Okay, 4x cube y square.
y square
So I got it as 3x square y plus 4x cube y square. Are they same?
No, ma'am.
Are this? No, they are not same. So what I will say? Since
Since
del m by del y is not same as del n by del x, therefore the given differential equation is not exact. Therefore, the given differential equation is not exact. So you're going to make it exact. Okay, so tell me in which rule number it will fit in. What do you think?
rule 2.
Homogeneous, ma'am.
Rule number,
1.
it's homogeneous. How can you see, how can you find this equation is homogeneous?
No,
Ma'am,
ma'am.
rule number 2.
2, 2, 2.
So so it is in the form of, it is looking like this, f1x comma y dx plus f2x comma y x dy equals to 0. So it is fitting in rule number 2. So we are going to use the formula for rule number 2 for integrating factor. So the formula will become 1 upon mx minus ny. So you multiply m with x and multiply n with y and you subtract them. So tell me what will be your m and n. So here is your m, this is your m. This you have to multiply with what?
X.
1 upon
So what should I write? So it will become x square. Tell me what it will become. X square. You're multiplying m with x. So it will become
X
x
square, Y
square
square,
y
plus
square plus 2x cube
Y
y
cube.
cube minus, now you multiply n with y, n with y. So
N
if I
X
multiply
square,
n,
X
so
square,
it will become
Y square,
x square y square, then
plus X cube,
plus
Y cube.
x cube y cube. So is there any term which is getting cancelled out?
ma'am.
Yes, say.
मैम हम लोग का
Right?
इक्वेशन एक्स वाई क्यूब प्लस 2x स्क्वायर वाई रेस टू 4 था ना
हाँ,
मैम.
हमने मल्टीप्लाई किया था पहले y.
हाँ, y पहले बाहर जाता उसको अंदर मल्टीप्लाई किया था.
Okay, so x cube y square, x cube y square it should come, no? Okay. So x cube I should write over here. X cube y
X square
square.
y cube.
x स्क्वायर y क्यूब x स्क्वायर y क्यूब
मैम
Okay,
फर्स्ट
okay.
टर्म एक्स स्क्वायर वाई क्यूब है डिनोमिनेटर में.
हाँ.
प्लस 2x
Then
क्यूब y रेस टू 4
देन नेक्स्ट टर्म इज 2x क्यूब वाई रेज टू
y रेस
4.
टू 4.
okay. Now it's fine. Is it fine now, बच्चा?
नहीं,
मैम सेकंड टर्म पहले माइनस के भी पहले.
mx वाले में मैम.
mx वाले में मैम. यस.
Okay, mix वाले में. Yes, tell me what should I write?
एक्स स्क्वायर वाई क्यूब
X square y cube. एक second.
मैम X से मल्टीप्लाई करना है ना.
हाँ तो
Yes,
पहले बाहर जो
mx.
y था पहले वो अंदर मल्टीप्लाई हो गया था ना इसके
हाँ
लिए.
वो भी होगा मैम. यस.
Yes.
तो एक्स स्क्वायर वाई क्यूब
X square y cube
प्लस 2x क्यूब
2x स्क्वायर.
y
हाँ
raised to
2x
4.
plus
क्यूब.
2x cube y raised to 4.
यस
Yes
मैम.
मैम.
Okay, then
माइनस
minus
एक्स क्यूब वाई स्क्वायर.
x cube y square.
I mean, I have solved it directly now, ma'am. So I'm telling that polynomial.
Okay, x cube y square, then
प्लस x रेस टू 4 y क्यूब.
x raised to 4 y cube.
x रेस टू 5 आएगा शायद.
You all
Next is
decide
नहीं,
first
x
what should I
x रेस
do.
टू 4 y क्यूब. हाँ बराबर है.
Okay, is there any term which is getting cancelled out? Is there any term which is getting cancelled out,
No,
kids?
ma'am. No.
Then there's something we did wrong. The terms will get cancelled out and you'll be getting only x cube, y cube. Okay, what the mistake we did over here? Can anybody tell me? Yes, anybody? Okay, what they have done, I can see in the textbook, they did not take this y and dx. So what they did in the textbook, they have taken only this as m and this as n, and they have solved the problem. They have not taken this y and x together, x in m and n, and using only the term which are in bracket, and they have solved it. So I think I need to see this problem again. I don't think so कि they should be avoiding y and x. What do you think,
हाँ मैम
guys?
लोग कंसीडर करना चाहिए मैम, क्योंकि हम लोग पहले
वही
ही
मैम।
इक्वेशन में मल्टीप्लाई किए थे।
Yes, so
Correct,
so they
correct.
have they have not considered that. So I think they have done some mistake. So that I will work on this problem again. I'll just check which one is the correct way, whether we should include y or whether we should not include y. So I will just confirm it and then we'll solve this problem in the next class. Okay, kids?
मैम
Okay. Yes,
मैम वो
yes.
होमोजेनियस वाला एक बार बताओ ना, होमोजेनियस कैसे चेक करना है? उसका डिग्री सेम
Homogeneous
है?
कैसे? Okay. See here. This is my given differential equation. Okay. Okay, so I have to check whether the given differential equation is homogeneous or not. How many terms are there? You can see over here. 1, 2,
3.
and 3. There are 3 terms present. We will look at the degree of the variable over here. Now, in this first term, the degree of variable is 2. Here, x is a variable and its degree is 2. Where in second term, there are 2 variable x and y, and they are of degree 1. So 1 plus 1 becomes 2. So this term was also of degree 2, this term is also of degree 2, and here the variable y is there only, and its degree is also 2. So each term is of degree 2, therefore it is a homogeneous differential equation. The same thing should happen in n also. So n should also have each term degree 2. So then it will become homogeneous differential equation. Now you got it?
Yes, ma'am. Thank you. Yes.
Okay. So kids, I'm giving you a homework question. I'll see that problem in the, like, what should be there, how it should be solved in next class. Okay. So you all take down the homework question, kids.
Ma'am, yesterday's problem?
Oh, yesterday's problem, what happened? You were not able to solve?
Ma'am, you told me you will discuss.
Okay. I'll discuss. Not an issue. So first you take down homework question. Okay, this is a homework question, kids. These 2 questions you'll have to solve. I think this will fit in rule number 3 and 4 respectively. Just see once whether you're able to solve these questions or not. Otherwise, हम ये दोनों question next lecture में solve करेंगे ही करेंगे. Okay?